So before I start, I want to begin with a chat that I had with some of your professors. So from the mathematics department. So this is off the record. I'm going to start my talk only after this incident. So I was talking to Sridevi ma'am, talking to Hari sir, I was talking to Karthikeyan sir and Shyama ma'am. And the topic revolved around AI. And they are in the mathematics department, and their concern was, with AI taking over the way it is doing today, what future do the students have? Will they have the basics in mathematics the way we used to have, earlier times versus, how students are going to be going forward? So that's how the conversation veered. And as we progressed, it looked as if it was almost like, the iconic film Nayagan, where the protagonist, Don Kamal Hassan, is asked, Ninga Nallavara Kettavara? And then he answers, Teriliyeppa. Like that, AI also in terms of usage, we don't know how it is going to go to, tomorrow as to whether students will be empowered to use it the way it should be or otherwise, right? That's entirely left to us. But we believe that it is going to empower everyone so that tomorrow's mathematics students hopefully are better grounded than they are even today. That's how we see the future. Yeah, with that, let's start proceedings. I'm Shankar, and I'll be talking about Cisco and how AI relates to us. Yeah, so that's going to be my topic. So this is going to be the agenda, right? So we have a little introduction. I want to talk about AI topology. I'll tell you as to what I mean when I get there. That's important. And I'll talk about three main areas. At the end of the talk, you can forget everything. But these three things, compute, network, and storage, and how they all come together for AI. That's the only thing I want you to remember. So that even if everything is lost in a blur, the first Kamala Hassan's dialogue you should remember, of course. And then you should remember compute, network, and storage. Yeah, we'll come to that. And then we're going to talk about NVIDIA because everyone who talks about AI and GPUs has to talk about NVIDIA. So we're going to talk about how we work with them. So that's why it's there. And then AI is not just about compute, network, and storage. It's how you manage it. And just like we talked about responsible AI, we have security coming in for AI as well. And we'll be talking about that. And last but not the least, as to how do you operationalize this whole thing? How do you troubleshoot? That's where the last topic comes in. So this is going to be our agenda. There's just one slide on each of them. Hopefully, I'm not going to bore you so that you can have it as a condensed kind of a presentation instead of it being kind of stretched out. We'll aim for that. So introduction, I wanted a slide, just to start proceeding. So this was just my go-to slide. Everyone, even when you're traveling by train, if you say that you work in a tech company, is going to ask you, what's your AI story, right? So that's, and then, of course, yeah, I just last week when I was going by in the cab in Bangalore, there was a new advertisement which had come which said, deep AI used for joint replacement surgery. So I don't know how they're going to use AI for joint replacement surgery, but we know that it's going to take over even those areas, yeah? So that's how pervasive AI is. So that said, don't want you to concentrate on all these buzzwords. The first and the last are enough for us. The first one, which says that there are companies out there called hyperscalers, and they deal in terms of having tens or hundreds of thousands of GPUs. Note that. And the last one, enterprises, right? Where I talk about hundreds or thousands of GPUs. Enterprises are, people like Walmart, whereas hyperscalers are the Googles of the world, Oracle, AWS, and others. So what I want you to appreciate from this slide, not the buzzwords themselves, but the fact that you have an entire range out there. People who use lots of GPUs as well as others who on a daily basis would use a smaller number. And we have to worry about that because the ecosystem provider for AI is Cisco. So we need to be sure that regardless of whether it's a hyperscaler or an enterprise, for these range of requirements, as we mention out here, we have the AI infrastructure, we have the AI ecosystem so that it can support such a disparate demand. So reference AI topology. So we will spend a little bit of time on this diagram, but this is the key to understanding as to what my topic is all about. So I do need to spend some time on this. So what we see out here in the middle are the servers, right? I'll be calling servers by the name compute. Yeah, that's just another word for servers, because that's where in these servers is where you have your GPUs sitting. And in those GPUs is where your LLM is getting trained and your AI applications are running, right? So the GPUs are inside those servers, that band in the middle, right? And that's where your AI application runs. And then below that, you see that there is a squiggly network, which is in blue. And these ones out here are the switches. These are the switches out here because you need to move the data from one GPU to the other GPU. We'll be talking about it. But essentially, to ensure that these servers can talk to each other, in terms of why we will see that later, but they do need to talk to each other. We need a network, right? Which is why we call this as our network. So this is compute. Yeah, I just talked about it. The band in the middle, the servers where your AI apps run on. So when ChatGPT runs, it runs on a GPU on one of these servers, right? And then you have the front-end network, right? The front-end network is the one through which queries, when you work with ChatGPT, you query it. How does it come to this server on which the application is running? It comes through the front-end network, which means it's the network through which a user, people like you and me, when we submit our query, comes through those switches at the top, which is the front-end network, and eventually it comes to the GPU running on the servers, which is going to do the actual work, right? So that's the front-end network. And we did see the back-end network as well, saying that, you know what, the GPUs need to talk to each other. We'll be talking about this as we proceed. I'm just setting the context, saying that, these are the things which are required. And you also need storage. Why do I need storage? Because how do you train your model? You would have heard about it, that ChatGPT to be trained took so much of time with so much of data. So it all has to sit in a storage. And how do you access the storage? The GPUs need to access the storage. So it's not going to be co-located as far as these servers are concerned. It again needs to go through the network in order to get the data so that training can happen for these applications, right? So yeah. So yeah, I just want to ensure that we have the big picture out here, because this is going to be the essence in terms of when I say AI ecosystem is what Cisco provides, AI infrastructure is what Cisco provides. I'm talking about this entire landscape, the servers, the GPUs, that's where your AI application runs. And then how do you train the models? It's when your GPUs talk to each other, for which you need the backend network, the one in blue, and then you need the front-end network, because that's how people like you and me, when we submit our queries, it comes to the GPU, which is going to eventually answer. And that's why you have the orange-based network, and those boxes at the top as well as the bottom are switches, right? So don't get confused between these boxes, which are the servers, versus these boxes, which are switches, which is how the handshaking happens between data going from one point to the other, right? And of course, we talked about storage as well. So hope this big picture, compute, meaning servers, network, divided it into two parts, the front and the back end, and then storage, right, come together. So compute, network, and storage. At the end of the talk, yeah, I hope we will all repeat as to what this ecosystem is all about, and I need to hear it loud and clear from all of you. It's compute, network, and storage. So I kind of put it out here, what compute is. We spoke about it. GPU, CPU-based servers, AI applications run there. Network, we divided it into two. We saw that. And storage, we talked about this. So this is just for me to ensure I covered it all. And Cisco, yes, we are involved in all these areas, as we will see going forward. That's why we provide the entire AI ecosystem. Compute. So we get into the details of each one of them. That's our job right now. So what are the servers that that Cisco supports, right? So when we talk about GPUs, right, that's the term that we use for these processors for large language models learning. They could be from NVIDIA, the company we hear about most. We hear also about AMD, and of course we always had Intel-based CPUs. So when we talk about these servers, it's just a diagram of two of them which Cisco markets. It's just to tell you the fact that we have servers in which we build it with NVIDIA-based GPUs. In this particular case, there are about 8 of them. The details don't matter, right? I just want you to appreciate the fact that Cisco makes servers which incorporates NVIDIA-based GPUs, and yes, those are the GPUs where your applications will run. And then you also need NICs. Why do we need these network interface cards? I'm sure you'd have read about it, because data, when it's there in the GPUs, has to move from one GPU to the other, which could be in a different server, in which case it has to go through the NIC, it has to go to the outside world also through, and that is also done via the NICs. And the NICs have to be really fast so that this can happen quickly, and that's why it says 400 gigabit per second. We also have 800 gigabit per second, which we will see out here. Is the audio going in and out, or it okay? Yeah. Is it okay right now? Yeah, you can hear me? Yes. Okay. So yeah, and of course, servers can be of various types, and we have NVIDIA-based GPUs, AMD GPUs. I mean, this is just for you to appreciate the fact that we have it all. Yeah, and what is the takeaway? That's the main thing. I want you to understand the fact that Cisco is in the server market for AI, and GPUs can be added all at once or even in steps by using, let's say I don't want 8 GPUs, I can add 2 at a time, and all that is possible, and we provide it all through our service. So that's the only takeaway. So from the compute, remember 3 things we said: compute, we studied about compute, and now we're going to go to the network. So why do we need a network for AI? So I have a set of questions and answers out here. I'm training my LLM. The job needs to run on multiple GPUs, right? So this is a possibility. And if the GPUs are within the same server, if they are within the same server, then no problem. They talk something called NVLink. You might have read about it. It's just a way in which GPUs within a given server, inside a given server, they can talk to each other using this model called NVLink. But if one server is not enough and we need to talk across servers, right? Maybe, I mean, there are different reasons. My LLM training itself is split over GPUs which span multiple servers, in which case I need to go across them. So for that, I need a network, and that's the backend network that we saw, the one in blue color. Remember the initial diagram, right? So we had that. And then how do I train my model? How can my server GPUs access it? For that, you have the storage network. Yeah, because as we saw, it's not going to be co-located. And yes, after my model is trained, how do I get queries from the user, people like you and me, to the server? It is through the front-end network, right? So in a sense, we saw all of this. I'm just reiterating the fact that network is such an important component, right? Comprising of 3 of them: the front end, the back end, as well as the storage network, for the reasons that we outlined. So that's why the network is at the heart of the AI infra. So I'm just putting this out as a refresher, but we went over this in detail. And I want you to spot some of these things. I mean, these are just terminologies, but good to remember that these networks are typically in a leaf spine format, right? So starting from the server, the first set of switches are called leaf, and the ones at the bottom will be the spine, and vice versa. If you start from these servers, the first ones will be leaf, and then you have the spine, right? So that's just terminology in terms of, yeah, Mike. Is it okay? Yeah. Yes. So, and storage network, we spoke about all the three of them, so don't want to go over it more. Yeah, so this we did this, we did this. Yeah, and again too, for the marketing spiel on this, as we see out here, we talked about compute and how Cisco makes servers with GPUs. And now coming to the network side, look at that. We make switches, yeah, those boxes, the back end and the front end, right? Which have our homegrown ASICs. That means that, Cisco makes its own hardware, right? Where we have ASICs, and that is also homegrown. And it's just a detail. You don't have to worry about it. But cloud scale ASICs, Silicon One ASICs, as well as port speeds of 400 gig and 800 gig. Remember, I told you that we have servers with NICs which are 800 gig and 400 gig. Similarly, the switches have to match that capacity as well, right? And then you need advanced QoS for AI. We'll be seeing that shortly because we want the network to be lossless. Yeah, so that's there. Are the requirements different for the front end and back end? Yeah, there are some differences. We'll just quickly go through that. The back end network, remember the one in blue that we looked at, how the servers talk to each other? And what does that do? It has GPU to GPU traffic, and it has to have these requirements. Of course, it's east-west, all right, but very high bandwidth, 800 gigabit per second, very low latency. It has to be lossless, and you have to maximize the throughput in terms of how you use the links. And for each of them, I just have a little detail in terms of how we do it. For very high bandwidth, as we saw, the NICs and the switches both should be able to provide that kind of capacity of 800 gigabit per second at this point in time. So we have that. For very low latency, you may want to look at this. There's something called RDMA. Rocky V2 is the name that we give for it, right? So that's a way to decrease the latency so that you need not go through the CPU or the kernel copy, as we call it, in order to ensure that the latency is less. It's just a way that within the server itself, I can move my data from my GPU memory to the NIC very quickly. So we'll be seeing an example, but this is just one way. And secondly, we connect the servers in such a way that you don't have to unnecessarily go through the spine layer unless required. So there's a technique to do that called rail. So these are two methods through which you reduce the latency. And why do I need to reduce the latency? So that my training of the LLM will be fast, right? So for that to happen, I need to ensure the latency is less. And for latency to be less, I have two methods out here, one of which is called RDMA within the server, as well as what we use is, a way of connecting the servers to the switches so that I don't have to go through multiple hops and can just go to the leaf layer and be back. Yeah. And then there, of course, quality of service, QoS, you'd have read about it in your networking classes. You need all of that to ensure that your network is lossless. And we have some methods for that. We don't have to get into the details, some explicit congestion notification, priority flow control. There are methods already there. So you need to use existing methods also to ensure that your AI network is lossless. And then, of course, the traditional methods in terms of how we send data over a link, they are not good enough so that you can distribute the data over the networks, in an efficient way. So we used to do it in something called 5-tuple ECMP. That's not good enough. So we have other methods now to ensure that we can do it in a better manner. So that's where the dynamic load balancing algorithms are coming to the picture. So that's why the network, especially the back end, is such a challenging piece because of so many things to take care. Your latency should be low, it should be lossless, and you should still be able to maximize the throughput. So these are just certain challenges that we have and how we are kind of working on them. Okay. And this is just an example. Since I spoke about RDMA, something to tell you that, what, the traditional way in which we used to send data out of the server. First of all, I need to tell you that this diagram is something which is within the server itself. So earlier we used to go through the CPU, through the kernel in order to get out of the switch. And now as we see out here, RDMA is a way of bypassing it. So you'll keep hearing this in AI terminology as to, the usage of RDMA, right? Um, so that you can bypass the kernel and get the latency lower. So that's something, to appreciate it. And this diagram, as I said, is just one server on one side. Remember those boxes that we drew in the middle? And another server on the other side, and how they work in tandem using RDMA so that the latency can be reduced. I don't want to get into the details of this. Just remember this, that traditional ECMP methods, like meaning methods to ensure that I keep my links well utilized, the way we used to do it in the past, are not good enough. And there are methods right now which are much better. There's something called flowlet. There's something called spraying the packet. Don't want to get into the details of this and kind of bore you. But just be informed that for AI, we've been forced to look at some of these things, anew one more time, just so that these kind of issues can be taken care, which we didn't have to worry about earlier. So this is that rail optimized design that I talked about, a very specific way in which we connect a server to switches. We didn't do it earlier. AI made this a requirement such that I connect my server GPU to the switches in a particular way so that I need not go through the spine layer at all unless required. So this is again a way for us to reduce the latency. Won't get into the details again, right? This is about the front end network. Remember the network, we divided it into two parts and then said front end is how user queries come in. So this is about that network. It is also called the north-south network, and it is not so bandwidth heavy since no training is involved here, but it must always be available because we don't want to get into a situation where you submit a query but then the switch is down and then you do not get the response in time, things like that. Yeah, so we looked at compute, remember? Then we looked at network. The third part is storage. Yeah, we'll be closing it very soon. So storage, why did we need it? We needed it for training, right? All the data has to reside somewhere. Yeah, and it is going to be in these servers. Again, this is a server that Cisco makes, petabytes of storage, and we're going to use it both during training as well as during inferencing. Yeah, and as shown in this diagram, it will not be co-located, right? The server running the GPUs where your LLM runs, and this storage, yeah, is not co-located, and that's why you need a network, a storage network to take care of this. And RDMA is used here as well because just like the other backend network we talked about, the storage network also has to be lossless. So you can read about this RDMA, it's available out there, methods through which we keep the network lossless. Yeah. This is again a marketing spiel for Cisco to tell you that, what, NVIDIA, as far as AI is concerned, is the prime company, right, in terms of GPUs and the splash that they make, and how we work with them. How Cisco servers use NVIDIA GPUs as well as our switches also. We work in tandem with NVIDIA. Yeah, so that the partnership is important so that we can take AI to greater heights. So having said all this, we talked about compute, network, and storage. I need a way to manage this. Remember this whole diagram that we talked about, the AI topology? It's so complicated. How do I, as a network administrator, keep track of this network in terms of, what each of this is doing, how my computer is doing, how my network switches are doing, how my storage is doing. For that, I need one pane of glass, as they say, right? So there are two ways you can do it. You can either have this management run on premises, on prem as we call, or it can be cloud based. That's why there are two of them stacks out here. Depending on how you want to manage, the same equipment can be managed through on premises or from the cloud. And for that we have, two products, some Nexus dashboard and Hyperfabric. Don't need to worry about the details, but just be informed that such a complicated network needs to be managed, and for that, network management is also done using these two applications. Yeah, so that's out here. And the two options I talked about. And security, yeah, we'll quickly go through it. What are the risks that we have to worry about? Yeah, this is responsible AI again in its own way. Is the model that I'm using? And why does Cisco worry about models? Because remember, like you, I'm also using these models to do my coding, right? So we have Copilot, that we use internally. So how do we ensure that my internal model is sane, or is it poisoned with data? Somebody has to worry about that and take care of it. And does my internal model have guardrails, as they call it, right? So that you don't ask it questions that it's not supposed to really worry about. And how do I ensure that I don't, while coding, inadvertently kind of submit code which goes to the outside world? It'll be a breach of confidentiality, right? So how do we do all of that? For that, we have one application, AI Defense. It's all over the place, so that if somebody makes a mistake such that he, inadvertently, he kind of tries to push the code which is internal to Cisco to the outside world, it is caught, right? So that's why it must cover the entire spectrum, access devices, laptops, firewalls. Wherever there's a possibility to catch this kind of a breach, it is caught. So just wanted to tell you that that is also done using AI, and that's why it is AI Defense. And last topic is operations. How do we troubleshoot this? Management we spoke about, right? I do need to troubleshoot my network as well, because a problem could be anywhere. As a person who works on a particular component, I may not be aware of all the things going on in compute, network, storage, to find out as to where the problem is, if and when there is a problem. How do we do that? There is a particular product called AI Canvas. So it uses AI to solve the problem as well, right? So AI ecosystem requires AI to troubleshoot. It's like using a thorn to remove a thorn, like that. So we have our own customized LLM to troubleshoot. It can troubleshoot across domains. It can make recommendations when it sees an issue, right? It can apply workarounds after asking you as to whether it's okay to apply the workaround. It's kind of a glass, a pane of glass, where you can invite other users, other experts, along with you, so that you can debug or troubleshoot a problem together. That's possible. And it can also display real-time telemetry data from the compute devices, from the switches, so that you can make informed debugging decisions. So all that can be done using one canvas. That's why it's called AI Canvas, right? So we looked at it all. So this is the last slide. So in short, Cisco is everywhere in the AI landscape. So what I want you to have as a takeaway is, we started with compute, network, and storage, right? So those are the three pillars. They've always been the three pillars of data centers, and now AI as well. And yes, Cisco, yes, has products in each of them. After looking at compute, network, and storage, we looked at the associated things in terms of how do we manage it, what is the security in it, and how we troubleshoot. And for all of them, we have corresponding applications to take care. So yeah, with that, I conclude my talk. Hope it was informative and useful to you. Thanks so much for your time.